With the release of version 7, we have tried to improve our routing engine by implementing all the dynamic routing protocols from scratch, while also adding some long-awaited features and improving the IPv6 stack. Maris, could you explain how this was possible?
As you already know, we have moved to a newer Linux kernel. One of the side effects of this move is that it came with a newer IP version 6 stack. Now compared to version 6, it has a lot of problems fixed, and also it will be more compliant with the RFC test. Also, the kernel update gave us possibility to set IP version 6 next hops for IP version 4 destinations. This feature is very helpful if you don't have IP version 4 addresses in your backbone, but forwarding of IP version 4 is needed. With this approach, it can be easily done without creating any tunnels and without wasting any IP version 4 or IP version 6 global addresses.
And so what are some of the new features for IP version 6?
Some of the long-awaited features are policy routing, recursive routing, ECMP, and finally VRF support. One very important routing table difference between version 6 and version 7 is that in version 6 you simply added mangle rule or added route and specified routing mark, and routing table was created for you. Now in version 7 you explicitly need to create routing table and only then reference in your configuration.
So and why was this new approach necessary? What is the benefit?
One huge benefit of this approach is that it will eliminate errors if table name was entered incorrectly, which resulted in non-working configuration, or probably because of typos, all the routing table names were hanging in the memory until a router was rebooted.
Also, I've heard that there previously were some problems with huge routing tables. So has this been improved in version 7, and how?
Yes, probably one of the most annoying things in RouterOS was waiting while print command is printing out something. The reason for this slow speed was the fact that console was asking routing process to send all the information, and then console processed the output. This leads to a situation where if you have a very large routing table, it could take up to 10 or 15 minutes or even more if you are not so lucky. Now the difference is that most of the filtering parameters are offloaded to routing process itself. So console just asks what it needs to receive, and routing process is doing all the calculations. This allowed us to increase speed from 10 minutes in version 6 to approximately 10 seconds in version 7.
Now let's move on to dynamic routing protocols specifically. So what is new in this regard?
Well, before we talk about dynamic protocols itself, one new feature is that now we have created a global router ID. Typically, you run a set of routing protocols in one instance with the same router ID. In router version 6, you had to change router IDs separately for OSPF, BGP, LDP, and so on. But now it's located in one place, and it can be easily changed if for some reason you need to do it. Also, this new router ID is used to distinguish between BGP instances, which reflects in completely different BGP configuration. But before talking about BGP, let's look a bit closer to OSPF. So in OSPF, now we don't have separate menus for OSPF version 2 and version 3. Configuration now is in a single menu, and to select which version you want to use, you simply specified in instance configuration the version number. Network and interface menus are also combined in single interface template menu, where order of entries are significant, just like firewall rules. They are processed from top to bottom, and first one that matches interface or network will be used. Probably most significant change in OSPF is that now it is a separate process, fixing many RouterOS version 6 problems where OSPF could lose connection because of high load from other routing protocols, missing routes, and so on.
So now let's talk about BGP, which was probably one of the most requested version 7 improvements. So what is new in BGP?
Long-lived BGP problems, starting with slow convergence speeds to even randomly disappearing BGP advertisements, as well as new features to keep BGP protocol up to date, led to decision to rewrite BGP completely from scratch. This allowed us to significantly reduce memory consumption, improve overall performance, and implement new frequently requested features. And this also resulted in a complete configuration redesign to accommodate these new features. Before we talk about features, here is a small demonstration on how quickly RouterOS version 7 BGP can process 2.4 million routes. This is a very simple one router setup where the router receives almost 600,000 routes from 4 separate BGP peers. Also make sure to look at the available memory information on the screen. As it can be seen from newly appeared process monitor, BGP is divided into multiple processes. Each peer now can have separate input and output, that way significantly improving performance on router with high peer count and high core count. Also take a look at memory usage now. You will see how little memory was used to store such a high amount of routes. It took approximately 200 megabytes.
If you're interested in more information about how multiprocessing works, we will leave a link in the description. But the previous test setup only demonstrates pure BGP speed. It doesn't reflect a real-life scenario. So how about BGP in real life?
Yes, so I have rigged a more advanced setup where the same router is receiving the same routes as in previous setup, but additionally router connects to 2 more routers which are interconnected between each other, forming the triangle setup. At the same time pushing around 5 gigabits of traffic to random destinations from one triangle side to another. Let's trigger a routing table recalculation by disabling, enabling upstream peers and see how much of our traffic will be dropped during convergence. This was quite a problematic setup in RouterOS version 6. Of course, it does not reflect the real-life scenario either, but it's a lot closer to show what you could get out of from RouterOS version 7 BGP. BGP performance further can be tuned with affinity control. It is possible to set how BGP input and output will be delivered by separate processes. You can run everything in the main process, run only input in the main, and so on. Since access of shared memory between multiple processes can be very expensive, use of affinity makes more sense on low-core devices where you can reduce amount of total processes even to one process that were removing shared memory access penalties. Another performance tweak is early cut feature. What it does is predetermines if a BGP update will be dropped by remote peer and simply doesn't send this update. For example, if BGP AS path contains remote peer's AS number, such update will be ignored in BGP output.
So what about memory usage? Has that been improved?
Yes, already mentioned memory usage improvements like 3.5 million routes using only 250 megabytes of RAM. Another example is if we compare to version 6, for fun I was trying to load one BGP feed on RB450 router, which has only 250 megabytes of RAM. On version 6, struggling for 9 minutes, router finally gave up and rebooted with out of memory. If we compare it to version 7, loading of routes took approximately 2 minutes, and at the end we got 120 megabytes of free RAM.
So this is good news for people using older devices. As you can see, RB450 is still supported in version 7 and is even faster than before.
I would say that it's quite a difference. Also, already mentioned route process monitoring tool. In addition to memory usage, CPU usage, and other useful info, you can kill unwanted processes.
While beta testing version 7, some users complained that parts of BGP configuration is gone. What about that?
Well, we got to the fun part where probably most of the hardcore BGP users that are used to all configuration will be very confused, because configuration has changed significantly. Biggest change is that instance and peer configurations are completely gone. Now we have new menus. One is BGP connections, another is BGP templates. You can call entries in BGP connections like connection matchers or connection initiators. It acts as connection initiator in case if you specify a single IP address and it is not set to be the passive. Templates contains common parameters that will be used for selected BGP connections. This approach was made because of dynamic peer support. What this allows us to do, for example, is set network range to listen to and connect remote peers based on template parameters. This is called dynamic peer configuration. BGP instance now can have parameters derived from common templates. Also, it allows us to set a chain of several templates with common parameters. And the last one is BGP now can guess remote AS number from open message, so you simply don't need to specify it in configuration. It can be used only for security reasons if you want to make sure that open message contains the correct AS number. For example, we know that our AS number is 10, so let's add this number to our default template configuration. We have also a set of peers that should be multiple hops away, so we can create a new template named multi-hop group and specify a template to inherit from. In this case, we are using default. Now we can create two connection entries, one with default template and another one with a multi-hop group template for multi-hop peers.
Another configuration option that people could not find is BGP networks. So where has that been moved?
BGP networks are not gone. It's now a parameter in BGP templates and can be set as an address list. Now you simply add the address list and specify all the networks that you want to advertise in that particular address list. Also, it is important to remember that synchronize option that was in version 6 are now gone. Now BGP takes entry from address list, checks if corresponding route exists in routing table, and only then tries to advertise it. If we look closer at template parameters, we can see that in addition to input filters, now we have also input accept parameters. What this does is match and accept BGP update messages directly before it's even processed by the main BGP process. This could allow to boost performance and significantly reduce memory consumption in cases if you know that you don't need the route in routing table. Since there is no possibility to drop routes in regular filters, these basic filters can be used to drop unwanted routes from the routing table.
So you mentioned basic filtering features of the templates, but what about regular BGP filters? What is new in that regard?
Those routing filters are completely redesigned too. Since we implemented a lot of new features there, configuration need to be changed a lot. So for example, now we have large community support, ability to match more than just a routing target in extended communities. Filter can access BGP parameters like local and remote AS numbers. We can also create community and number lists to match against. And the very important feature asked a lot was that now you can add, subtract and replace number parameters. For example, if you have OSPF metric, you can simply add it to BGP local preference. Some important things about a new routing filter syntax is that now one routing filter entry can have only one set property, which means that if you want to change multiple parameters, you will have to divide this filter in multiple entries. Multiple filter entries without actions are stacked in a single rule. The reason for this change is that order of parameter sets is very important, and writing one parameter set per line allows for easier understanding from top to bottom on what actions exactly were made. And lastly, the frequently asked feature is router region validation, also called as RPKI. RouterOS implements RTR protocol, which sends a list of prefixes and originator AS numbers. Based on this information, RouterOS can determine whether AS path of the prefix contains originator AS number and sets the correct flag whether the route is invalid, valid, or information is unknown. And this flag further can be used in routing filters to drop or reject or do whatever you want.
These were some of the most important changes in version 7 routing, but we also have made a special page in our documentation where we will list these and other changes in version 7, also BGP and other routing protocol improvements, speed tests and other information. We'll put the link to this documentation page in the description of this video. So you can already download RouterOS version 7. It's available as a beta version. You can install it in a virtual machine or upgrade one of your test routers and see how well it works for you and try out the new configuration options.